Hi everyone, today we are reviewing for the ratios and proportional reasoning test. So you should be watching this video to review for the test. You should also be copying the problems onto the Jamboard assignment or on a separate piece of paper, which is totally fine, and then just make sure you email it to me. And you are going to submit this for a classwork grade. So this is an easy 100 in the grade book. All you have to do is watch the video and copy the problems. Okay, so this is how you're going to be reviewing for your test that will be tomorrow. Let's get started. First one says, when a grizzly bear hibernates, its heart rate drops to 10 beats per minute, which is 20% of its normal heart rate. What is the normal heart rate? So this is a percent problem. So we can either use the percent proportion, which is over of equals percent over 100, or you can use is equals percent times of, which is the percent equation. It doesn't matter which one you use. I'm going to show you how to use the percent proportion because I feel like that's what most of you guys lean to the most. So we know right away that 20% is the percent here. So I'm going to put that over 100 because that's, again, where the percent goes. And then we're going to go through and look for is or of, but also part over whole. You can think of it like that as well. But I do see which is 20% of its normal heart rate. What is the normal heart rate? That means we don't know what the normal heart rate is, and that's what of is. So I'm going to put an X in the denominator, which leaves 10 to be in the numerator. So I'm going to cross multiply and solve here. So I have 20 times X, which is 20X, and I have 100 times 10. I'm going to take 100 and add one more zero to it. But don't forget, you can use Desmos. Then I'm going to divide each side by 20. So I have 1,000 divided by 20. I'm going to plug that into Desmos here, and I'm going to get 50 as my answer. So X equals 50. So that means the normal heart rate is 50 beats per minute. So we should be remembering how to solve percent problems for this test. Next, which size of yogurt shown in the table has the lowest unit price? Remember, unit price is where we take the price and we divide it by whatever it is, size or amount or whatever. In this case, we have the size in ounces. And remember, when we're finding a unit price or a unit rate, we also know that money always goes on top. So we have money divided by ounces. So my first one, I'm going to take 89 cents and I'm going to divide by 6 ounces. So I'm going to use my calculator, 0.89 divided by 6. Now we are talking about money here, so I do want to round this to the nearest cent. So I'm going to stop at 0.14, but I do look next door and there's an 8. Okay, so 8 or above, not 8 or above, 5 or above, give it a shove, which means this 4 is going to become 5. So it's approximately 15 cents per 1 ounce. Okay, so again, this one is 15 cents per ounce. Now let's do the next one. We have $1.04 divided by 8 ounces. So how much is 1 ounce? So 104 divided by 8. Oops, it would help if I was typing in there. 104 divided by 8 gives me 13. So the next one, we have 13 cents per ounce. Let's move on to the next one. $1.69 for 10 ounces. 1.69 divided by 10, and I get 0.169. I do want to round this one, so it ends at the 6. This 9 is going to make this 6 go up to a 7. So I have 17 cents per ounce. And I have one more, 4.79 divided by 32 ounces. So how much money is that for 1 ounce? So 4.79 divided by 32. Yep, 32. Oh boy. Make sure you're in the denominator. And I have to round this one. I'm going to stop at the 4. This 9 next door is going to make this 4 go up to a 5. So that is 15 cents per ounce. Okay, so which one is the lowest? 15, 13, 17, or 15? Well, 13 is the lowest, and that's the 8-ounce container. So the 8-ounce one is the answer here. So again, when we're looking for the lowest, or it could say the highest unit price, you're just finding the unit rate. Divide them. Remember, money usually always goes on top here. Next, Kevin can travel 22.5 miles in 1/3 of an hour. What is his average speed in miles per hour? Well, miles per hour, I'm going to divide them. 22.5 miles divided by 1/3 hour. Just going to plug that right in here. 22, and I'm going to hit a B. Oops, 22.5 divided by 1/3. Divided by 1/3. 67.5. So I come back here and I do see that as choice B, 67.5. Okay, so again, miles, distance usually goes in the numerator and time usually goes in the denominator. Next, the table shows the cost for ordering a certain number of pizzas. What is the value of X if the cost is proportional to the number of pizzas ordered? So if it is proportional, remember, a table is proportional if the unit rate is constant. Okay, so here we would find the unit rate by taking the price and dividing it by the number of pizzas. So 1998 divided by 2. This will tell us how much one pizza costs. One pizza costs $9.99. $9.99 for one pizza. Well, we want to know how much 5 pizzas is. So we're just going to take this $9.99 and multiply it by 5. $9.99 times 5 gives me $49.95. So that should be a choice here, and it is choice C. Okay, so remember, a table is proportional if the unit rate is constant. All right, what is the constant rate of change shown in the graph below? So the constant rate of change is, remember, it's always y over x here, okay? So we're going to pick 2 points. It doesn't matter what 2 points. We're going to pick any 2 we want. I always like 0, 0. And we're going to set that up as a table. 0, 0. And here's another point here, 2, 6. So we're going to see how are they changing. The x values are changing by 2. The y values are changing by 6. But remember, it's always y over x. So how are the y values changing? They're changing by 6. How are the x values changing? They were changing by 2. 6 divided by 2 is 3 over 1, or just 3. So B is going to be my final answer here because the constant rate of change is 3. Don't forget, we should be copying this down because you are handing it in as a classwork assignment. What is the constant rate of change of the table below? So this is very similar. We set up a table before from the graph, but here we're going to just figure out how the graph is changing. How the table is changing. So remember, whenever we have a table, we always have x first and then y. So we're going to see how are the x values changing. We're going from 10 to 20, 20 to 30, 30 to 40. We can see that it's changing by 10 each time. And for the y values, which is meters, we have 40 to 80, 80 to 120, 120 to 160. So it looks like it's changing by 40 each time. Now remember, it's always y over x. So the change in the y values was 40 over the change in the x values, which was 10. And we can simplify that to be 4 over 1. So we can put meters, right? Y was meters, X was seconds. So it is 4 meters per second, which is choice B. Next, what is the slope of the line? So slope, this is where we had that formula. Let me write it down. So this formula was m equals y2 minus y1 over x2 minus x1. And this is again where we pick 2 points. So I'm going to pick the point 0, 0. And another point that I'm going to pick is 2, 30. So after I pick my 2 points, it does not matter what 2 points you pick. You would still get the same answer. But I do want to label my first point, x1, y1. And my second point, x2, y2. Because again, this was my first point. This was my second point. So x1, y1, second point, x2, y2. And then I'm just going to take what I labeled and plug it right back into my formula. So m equals y2, which is 30, minus y1, which is 0, over x2, which is 2, minus x1, which is 0. Then I'm going to simplify. So 30 minus 0 is 30. 2 minus 2 is 2. And here, when it's slope, you do want to simplify it. If you can, you don't want it to be a decimal. But 30 divided by 2, I can simplify to be 15 over 1 or just 15. So it looks like A is my answer here. Next, we have scale drawings. It says a scale drawing of a house is shown. What are the actual dimensions of the lounge? So I can see here we have the scale. Okay, 1 centimeter equals 5 feet. That's important. So we're going to figure out the lounge. Let's see, we have it right here. So what are the actual dimensions? So it's length and width. So the length is 4 centimeters. The width is 3 centimeters. So we have to use our scale here to figure out the actual dimensions. These are the dimensions on the drawing. So I'm going to always start scale drawings by writing my scale as a fraction. 1 centimeter over 5 feet equals, I'm going to start here with 4 centimeters. So I'm going to put 4 centimeters in the numerator because I want it to be equal with the other fraction. So centimeters, centimeters, both in the numerator. That leaves x feet to be in the denominator. Now I want to solve this proportion. 5 times 4 is 20. 1 times x is x. So therefore I have 20 is equal to x, and x was feet. So I'm just going to make a little bit of room here, and I want it to be 20 feet. So this is 20 feet. I'm going to do the same thing for the width, which is 3 centimeters. But again, I'm going to use my scale. 1 centimeter over 5 feet equals, so I have 3 centimeters. Again, I'm going to put that in the numerator because I want centimeters and centimeters to line up. They should be equal, which leaves x in the denominator, and I have x feet. Cross multiply, so I have x times 1 is 1x, or just x. 5 times 3 is 15, but again, I'm looking for feet. So this should be 15 feet. So the actual dimensions are 20 feet by 15 feet, which is choice B. All right, we are solving the following proportion. So this is a short answer problem. You do have to show all work when it comes time for the test. Okay, since this is review, you should be copying everything down for the multiple choice in order to receive full credit on it. However, for the test, the multiple choice, you don't have to. Would it be helpful? Probably, because did you see all that work we just did? We probably should be writing something down, but again, multiple choice is not required to show work. Short answer is. So let's go ahead and cross multiply here. So I have k times 0.5, which is 0.5k. And then I have 13 times 0.6, which I'm going to come over here and multiply. So I got 7.8. And my final step here is to divide both sides by 0.5. So 7.8 divided by 0.5, I get 15.6. And that's it, my final answer. Next, does the following table show a proportional relationship? Show your work and explain. So remember, we know a table is proportional if the unit rates are constant or if they're all the same. So just like in the example, I think it was like the second or third example, we had to find the unit rate or the unit price. We're going to do the same thing here. So we're going to do 549 over 24 ounces. We want to know how much money for 1 ounce. So 549 divided by 24. Oh boy, make sure you're in the denominator. And I get 0.22875. So since I want to make sure they are exactly the same, I'm going to copy that down exactly as it is, 0.22875. I want to make sure all of them are this same exact number, okay, because it's asking if it's proportional or not. So I'm going to do the next one, $8 divided by 40 ounces. How much money for 1 ounce? So $8 divided by 40 gives me 0.2. All right, so since they are not the same, I don't have to do the last one because right away I know this is not proportional. Okay, so I'm going to write non-proportional. Make that a little bit bigger. Non-proportional because the unit rates are not the same. Okay, if they are not the same, it is not proportional. So if you're doing this and you're getting the same thing over and over, you want to make sure you show it for all of them, and you would say it is proportional because the unit rates are the same. But in this case, we have different unit rates, so it is not proportional because the unit rates are not the same. Next one, if it takes 15 gallons of gas to drive 330 miles, how many miles can be driven using 20 gallons of gas? Write and solve a proportion. All right, so we're going to solve this writing a proportion. So we're going to take our first piece of information, we're going to write that as a fraction. 330 miles over 15 gallons equals, well, we have 20 gallons. Since this is a proportion, gallons have to be lined up with gallons, in this case in the denominator. We don't know how many miles, so that's X miles. So we're going to solve this proportion. So we cross multiply. 15 times X is 15X. 330 times 20 gives me 6,600. Last, I'm going to divide both sides by 15. So 6,600 divided by 15 gets me 440. So to answer the question here, how many miles can be driven using 20 gallons of gas? We're going to say 440 miles can be driven using 20 gallons of gas. We're just turning the question around here. Okay, we're rewriting the question as a complete sentence. Please make sure again that you're copying everything down so you can submit this for a classwork grade. Next, Sally can travel 342 miles in 6 hours. Write an equation relating miles traveled and time in hours. Use the equation to find out how far she can travel in 5 hours. This one we must write an equation. Yes, you can write a proportion. However, you need to follow directions and it's asking for an equation. So the first thing that we always do when we're writing an equation is to take our information and find the unit rate. So we have 342 miles in 6 hours. So we're going to divide that, 342 divided by 6, that gets me 57. So 57 miles per hour. What we just found here is K. K is equal to 57. Because remember, we want our equation to be y equals kx. Now we want to write our let statements. Y and x have to be equal to something, right? But remember, from our unit rate, it's always y over x. So the units that go with y is miles, and the units that go with x are hours. So this will help us when it comes time to plug in the information to actually answer the problem. So since we have our unit rate, we know we have y equals kx. Now we're actually going to write our equation. Y and x are going to stay the same. The only thing that changes is k. We know k is 57. So this right here, y equals 57x, this is our equation that it's asking for you to write. Write an equation, that's the first part of the question. This is the equation. This is what I have to see on your test in order to get full credit for this problem. Now we can go to the next part and it says, how far can she travel in 5 hours? Well, hours is x. So we're going to take 5 and plug it in for x. So we have y equals 57 times 5. So in order to simplify this, we just multiply 57 times 5, which gives me 285. So we should write a sentence explaining what this 285 means. It says, how far can she travel in 5 hours? She can travel 285 miles in 5 hours. Pause if you need to so you can copy. Next one, the length of a drawing of a mug is shown below. The scale is 1 centimeter equals 3 inches. What is the actual height of the mug? So we must write a proportion. So we have 1 centimeter over 3 inches. We always want to write our scale as a fraction. Then we know we have a second fraction, which is going to be the same, centimeters over inches. We're given 2 centimeters, so we're going to plug in a 2 here, which leaves an x in the denominator. So we're going to cross multiply. 1 times x is x. 3 times 2 is 6. And 6 is already by itself, so that's it. We're done. The only thing that's missing here are the units. It says x inches, so 6 inches is going to be our final answer. Last problem, determine whether the relationship between the two quantities shown in the table is proportional by graphing on the coordinate plane. So remember, a graph is proportional if the line is straight and if it passes through the origin. Those are the two things we need to be looking for. So first we need to graph these points here. So I'm going to zoom in a little bit. And I'm going to graph the point 1, 8. So 1, 8 is about here. And I do 4, 32. And 7, 56. Okay, so we want to draw a straight line connecting them. Well, we have to see if it's straight. Now remember the little trick? When we click shift, so I'm going to click on this point here. I'm going to hold down shift while I do so. This way I get a nice straight line. So I can see that my line is lined up with these points and that it goes through the origin. Remember, the origin is the point 0, 0. So for this question, it's asking if this is proportional. And we're going to say, yes, it is proportional because the line is straight and it passes through the origin. Okay, please don't say that it goes straight through the origin, because the line can go straight through the origin right here, but then it could be a little funky up here and not be a straight line anymore. So please make sure you differentiate that the line is straight and it also passes through the origin. Okay, so these are all the different topics that you could see on your test tomorrow. I will tell you that your test will look very similar to this, with multiple choice problems, with short answer problems. So please make sure you have all of this copied down so you can hand it in by tomorrow before your test, because this is what's going to help you study. So if you have any further questions, please reach out and let me know.